Hi kids. Today we're going to learn about periodic trends. Now, periodic trends is kind of redundant. Do you know what redundant means? Well, if you don't, you should look it up in the dictionary. If you look up redundant in the dictionary, it says, see redundant. What periodic means it appears over and over again. And trend also means it appears over and over again. So when I say periodic trends, I'm seeing over and over and over and over. It's like that kid that wears the shirt that says, how do you keep an idiot busy for hours? Turn around. And you turn around, it's got the same thing on the back. That's what we're doing today, periodic trends. Up here we've got an abbreviated periodic table. Now what we've done with this periodic table is we've crushed it down. Now I have demonstrated on this little sheet here what we have done. I have taken out what's called the transition elements. We have transitioned them elsewhere. So we just get rid of them, we smash the periodic table down. So this abbreviated periodic table is going to be the first two columns and then the last six. Okay? They just make working with the periodic table much easier. We can have a lot more trends if we just do it that way. So just so we kind of know exactly what elements we're dealing with, I'm just going to start just a couple of them. I have my hydrogen up here. This guy over here is helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, I'll let you fill in the rest of them. But that's kind of what we're dealing with here. Now, things that I'm looking for. Okay, it is a periodic table. There are things that are going to be happening over and over again. So one of the things we see energy levels getting higher and higher. And I can see that by these layers getting bigger and bigger and bigger. So this is the energy level of 1. It's the first row. This is the energy level of 2, second row. And we keep on getting bigger and bigger. Now ultimately we're going to go up to an energy level of 7, but we're not going to be dealing with those just yet. Alright, as we go across, these are going to be what we call our columns, or our families. So our families are going to work like this. Okay, we're going to go over family names next week, but until we get there, I'm just going to call them Group 1, Group 2, Group 3, and so on. Okay, we're dealing with a grand total of 8 groups today. Now, when we work through these, I'm going to show you some things that we see, and we'll start developing these trends just right off the bat. All right, with hydrogen. Hydrogen has 1 proton. That's a positive. So it's going to have 1 electron. It's set. Now helium has 2 electrons in its valence shell, or its outermost shell. And its outermost shell is full. Then it is happy. I'm going to draw a little smiley face because he's a happy little guy out there. Okay, now lithium. Lithium has another shell outside of that shell right there. So there's actually 2 little electrons in here. But I don't represent those when I'm drawing just valence electrons, which is what I'm doing right here. So I'm just going to get rid of those. So we're dealing with the outer shell. Lithium has, since it's in the first column, 1 valence shell. Beryllium has 1, 2. Boron has 1, 2, 3. Carbon, 1, 2, 3. Remember how we did this? We skipped that one. We don't buddy up yet. Nitrogen, 1, 2, 3, 4, 5. Oxygen, 1, 2, 3, 4, 5. Now we're going to start buddying up. Fluorine. We've buddied up once and twice. And then neon. Look at what we've done here. We are full. And what do we say about something is full? It is happy. So now I can observe that I have a trend here of, in this last column, I've got 2 things that are full. That's a good thing. That's important. If I look at my first column, I see that I have just 1 valence electron in each one. If I were to continue that, this whole column would be 1 valence electron. This one, you would see that it has 2 valence electrons. This column, I'm pretty good at counting, can go to 3, 4, 5, 6, 7, and 8. So if you can count to 8 in chemistry, you pretty much got it made. Now, ultimately what we want to do is we want to be happy. Everybody wants to be happy. These are the cool kids. Now, I have multiple options of getting happy. I can either take away electrons or I can gain electrons. Now, fluorine is really, really close to being a cool kid. Fluorine needs how many electrons? 1. So in order to get an electron, he's got to take it from somebody or share it from somebody. But if he gets that, if I were to add an electron to this, ultimately what would happen is fluorine would have what's called a negative charge. Now the reason it has a negative charge is because what's the charge of an electron? It's negative. So if I have a negative electron that is being joined to what was normally a neutral atom, it's now going to be a negative charge. Now this whole column here needs 2 electrons. So if it were to get 2 electrons, it would be, let me write it up here, sorry, real quick. It would be 2 negative. This one needs 3, so it would be 3 negative. I'm going to jump over to the other side real quick before I go to the middle one. Carbon, he's a little tricky sometimes. Okay, lithium. Lithium only has 1. Okay, is it easier for it to gain 7 or lose 1? If it loses 1, it becomes like helium, and helium's happy. If it gains 7, it would be like neon, and neon's happy. It just takes too much energy, though, to get 7 more electrons. It's really easy to get rid of one. So if he gets rid of an electron, he becomes positive. You can think of it this way. In your life, if you get rid of negatives, so if you have a bad habit or whatever, overall you just become more positive. So this row here, we can say it's going to be 1 positive. Because if he loses an electron, he becomes what I call old school cool, like helium. Beryllium, if it loses, he needs to lose 2. So he is 2 positive. Boron, 3, so it's 3 positive. And now we come to our friend carbon, which we talked about just a little bit ago. Okay, now we're stuck between the 3 positive and the 3 negative. Okay, and that's what makes carbon so special, is that it can either be 4 positive or negative. Okay, these are very simple things. We're going to do a lot of work with them in knowing that this whole column is a 1 positive, this whole column is a 2 positive, this whole column is a 1 negative, this one's a 2 negative, 3 negative. We'll just know that right off the bat. We'll be able to pick up on that really fast. Next, I want to move on to atomic radius. Now remember, radius is going to be half of the distance across. So as we get larger, obviously our radius is going to get bigger. So when I first start off here, this has a small energy level. The reason it has a small energy level is there's only 1. So if there's only 1, it's going to be kept really, really close to the nucleus of the atom. Later on in class, I'll tell you about Farmer Brown chicken theory. So if we're really close here, 1 energy level, 1 energy level, both of them are going to be fairly close. Okay, that's the first energy level. But notice as I get more and more energy levels, it starts getting wider and wider and wider. Okay, so that's a trend that we're going to notice as I go down the periodic table and add more energy levels, my atomic radius will increase. Okay, that's a really, really important trend for us. Okay, because these things, it's going to tell us how easy they react with other things, how easy they pick up other electrons. Okay, as I'm moving across the periodic table, as I'm doing the group trends here, you'll notice that I start off with a really, really large radius, and it gets smaller and smaller as I go across. Okay, now the reasoning for that is, let's think about it. How many protons and neutrons are in this nucleus here of lithium? Okay, lithium has an atomic number of 3. It has a mass number of 6. So I have a grand total of 6 little guys in there. Okay, they all have an atomic mass unit of 1. So I have an atomic mass unit of 6 in there. Sorry, that's a bad 6, but that is a 6. Okay, if I come all the way over here, I'm not going to talk about these guys just yet. There's several different properties that we're not going to deal with yet. But let's talk about this halogen group, this group 7. That's fluorine. So if I look at fluorine, he's got 9 protons and he's got 10 neutrons, generally. So his number is 19. He has a mass unit of 19 in there. Now, to simplify things, let's think of it in terms of gravity. Now, this isn't a gravitational force, it's a nuclear force, but let's just think about it in terms of gravity. If I have something that has a mass of 6, if it's like a small sun, it's not going to be able to pull in as much as something that's larger. Okay, so what I have here is the small one, so it's going to be wide, which makes my atomic radius large. This one has a large nucleus, so it pulls everything in tight, which makes the radius small. So our trend in atomic size is going to be, as I move across the periodic table, I decrease. Now, oftentimes I'm going to draw just with one arrow. So if I say draw with one arrow across the periodic table, which way the trend goes as far as like increasing, my increasing trend would be from the top right-hand corner down to the bottom. And what we can see here is I have a very small atom and I have a very large atom. Alright, here's tonight's video added bonus. Next week you have NWEAs, Tuesday, Wednesday. If you not only get the top score, but you say, hey, Mr. Brewer, watch the video. Let's see what's going on here. Did I get the top score? If you would ask me about how you did and relate it to the video, and you did get the top score, I will add 10 points to your grade. So good luck and Godspeed.